for... All right, so this time we're going to learn the ambiguous case of the sine law. And we know where sine is ambiguous because we can have two angles with the same sine ratio. What are those two angles that would have the same sine ratio? Supplementary angles, correct. So let's try and investigate this ambiguous sine law or ambiguous case of the sine law using this activity here. We're going to do an activity. So first, we'll draw a diagram. We know that in any triangle, we can label the full pair as the angle and the side across it, right? So let's say I'm given angle 30 degrees. So let's say this is my angle here. And I'm just estimating, let's say that's 30 degrees. And this is angle A. So the angle that I'm given, I always plot it because, you know, when you're going to find it later on your own, you're going to have to plot the angle that you're given as the base left angle. So again, you want it to be the base left angle, just easier to read that way. So the angle you're given, because in the ambiguous case of the sine law, that type of ambiguity only applies to side angle. So that means you will be given one angle all the time and two other sides. All right. So you're going to be given an angle and a side opposite and another side. So the angle that's given in your side angle, you need to plot it on the base left angle. Right? Any questions? We good? All right. Before we start this, they gave us B. Okay, they gave us angle B. And B is right here. Okay, I'm going to write B. So in here, they gave us angle A and angle B. Now we want to figure out how can we make a triangle out of this? What is the smallest side length opposite angle A that will complete that triangle? The smallest side length to complete that triangle is the height, which is a right triangle. That's the smallest side length that can complete your triangle there. So right now we know that this here, the side that is half pair is B. Okay, we're given B as 6. We don't know the angle, so we put the B here, and the 6 will be kind of the side that's attached to our angle. So right now, our goal is to figure out a side length that will complete this triangle, meaning we want to see the side length opposite A that will complete it. So what is the smallest? What is the smallest side length that will complete this triangle? So that is our goal. We want to see what number, what length would complete that triangle. And the smallest is the right triangle, right? Which is the height. That is the smallest side length that will complete this triangle if I have an angle 30 degrees and the opposite side of the angle B, sorry, I put it in the wrong spot. And the opposite of angle B given. So here is angle B right here. How do I get that height? How do I get that height? This height right here, how do I get it? The sine SOHCAHTOA, right? SOHCAHTOA. So let's see. Sine of 30 degrees is equal to the opposite side over the hypotenuse 6. So H then is equal to 6 times sine 30 degrees. And H is equal to, what is that equal to? Sine 30, 3. So 3. So 3 units. So that means if I have an angle 30 degrees and the side adjacent to it is 6, I need at least 3 length or 3 unit side length to complete my triangle. Now you have to think of this. What if the opposite side given to A is smaller than 3? Can I make a triangle? No. If I get a side length opposite A that's larger than 3, can I make a triangle? Yes, because you can just arrange it like at an incline like this and make a triangle, isn't it? Now if it's longer, if it's longer than 3, you can position it this way. And if it's longer, okay, hold on. If it's longer than 3, let's say 4, can I position it right here? Let's say 4, just a little bit longer than 3, right? And if that side length is longer than H, but smaller than the 6, that means I can also position the 4 right here. And that's where the 2 triangles come in. You see it? So you have a triangle like this one here, if I highlight it. That's one of them. And here's another one. This one. There are 2 of them. So we'll do more of that, okay? So I'm just going to take that off. I'm just giving you a little, uh-oh. Okay, I have to take them off. Right. So now we have to remember that every time we have an SSA situation, we want to solve for the height first, because the height will determine whether we can have one triangle or no triangle. And we know when we cannot have a triangle. When can we not have a triangle? If the side length given opposite that angle is smaller than its height, right? So we can't have a triangle that way because it's too short. How can you make a triangle? All right. But if it's short, if it's longer, then we can either have 1 or 2. If it's longer than the 6, then there's no way you can position it over here. Like I'm going to show you with this here because it's kind of hard to do it on the paper. So I need a little ruler or something. Okay. So anyway, so if let's say this is my side length. Let me grab a ruler because you can see it better with the ruler. I'm not. So if the height is our baseline, right? So the height, because remember for SSA you will be given this side length and another side. So you're going to check if the height given, meaning the opposite of the angle given, is larger than the height, because that's the smallest that you can make a triangle. So if our side, if this is 6 here, if the side length given is 6, less than 6, then that means if I position it here, I can make a triangle. And if I position it this way, I will not go past the 6. Right? This is smaller. So that means if I have the opposite side of the angle higher than or larger than the height, but less than this, then I can have 2 times. But if I have the opposite side given greater than this, then I can only position it this way. Because if I move it this side, it will go past 6, and there's no triangle going back to that. All right, so we're going to do more exploration here with the notes that I gave you. All right, so using a ruler, I don't have a ruler. So in here, they said that, let's see, with angle 30 degrees, what if I'm given a 30-degree angle? I'm given a 30-degree angle. And again, we are going to put that as the base left angle. And the side given to us is 2. Okay, so they said, all right, here's the side given, it's 2. Side given here, the opposite. Right, so if you look at the top, in each triangle given there, we have angle A, that's 30 degrees. We have side B as 6, and we have side A given as 2, right? So again, A, the angle given should be your base left angle, and the opposite side should have the angle. The pair of the opposite side should be the base right angle. So that means this is where we should put our B. This is where we should put our B. The B is 6. And they gave us 2 for A. Now question, is that 2 big enough to make a triangle? Let's check the height. Every time we're given an SSA situation, we need to find the height. So let's solve for the height first. So sine of 30 is equal to h. Okay, we're going to check the height just to see if that side given is greater than the 2 or less than the 2. So the height, check the height all the time, guys. If you have an SSA triangle, check the height. So sine 30 is equal to the height over 6. And we know that h is equal to 6 sine 30. And h is equal to 3. So now look at this. The required height, the minimum height that will create a triangle is 3. And you're given 2 for the opposite side of A. Is it possible to have a triangle? No. Why is it impossible then to get the triangle? In here, A is too short. To form a triangle. Too short. Can't make it. So now let's go back and look. So in this case then, if triangle A, if angle A is acute and the opposite side is what? And the opposite side is smaller than the what? Is shorter. Sorry, I didn't give you enough space. Shorter than H. We know what H is. There is no triangle possible. So how do we do that? So if the opposite side of the given angle is smaller or shorter than the height, then no triangle is possible. How do we write that in symbol so that it will be easier to remember? So here, A less than height, okay? So if the A, and remember, what is that A? What is that A? A is the opposite side of the given angle. Remember? Then, so if the opposite side of the given angle is smaller than the height, then what happens? No triangle possible. So that's what it means. Right? Let's go to the next one. So the next one, again, we're given the same numbers here. So again, A is, oopsie, stop. So A is 30 degrees again. B is still 6. And then A is this time 3. 3. So we draw a triangle. The base left angle is our A. The base right is the half pair, okay? The angle of the other side given. And they said that A is, sorry. A is what? 3, it says. So A is 3. That's what they say. And the angle here is 30 degrees. This is an SSA, so we check the height first. So check the height. Sine, we kind of know what the height is, but I just want to keep going. H over 6, and then h is equal to 6 sine 30 degrees. H is equal to 3. So, so the height is exactly the same length as the side given, the opposite side of the angle given. So is there a triangle if the height is equal to the opposite side given? Yes. So how many triangles? Just one. What kind of triangle? A right triangle. So, okay, wait, that's not the right color. When A is equal H, there is one triangle. The triangle is a right triangle. Because that's exactly the length you need to create a right triangle. Okay, so how do we write this in symbols? So when A is equal to H, therefore we have one right triangle. All right, let's go to the next one. Next one. So this time we are given the same numbers, right? So A is equal to 30 degrees, B is 6, C is, no, not C. A is, they gave us 4 here. So A is 4. Let's draw our base left angle, which is 30 degrees. A. And here is B. We don't know if we're going to form a triangle here or not. But we know this is 30. And here is 6. And let's see. Here is the height. And we know the height is, what is the height? 3. Remember, 3 is the height. Now they gave us 4. A is 4. Now let me ask you something here. If A is 4, is A going to be bigger than the height? Yeah. So I can extend this line here. So let me extend my line. So I'm going to extend this and extend it that way. So 4 is greater than 3, isn't it? So definitely there's one triangle. So the triangle I can position here. So let me get a color. So I can position that triangle over here. A little bit bigger than. Yeah? So that's one of the triangles I can see. All right. So that one is the acute triangle. Okay. This is the acute triangle here. If I highlight that triangle, this is our acute triangle. Now in the next, on the next page, we're going to draw the other one. Okay, so this is 4. This here is 4. Why are we able to position it like that? Because it's longer than the height. So you have to move it farther out, incline it to make a triangle. But is that 4 less than the 6? Yes. So that means I can also position it inside this triangle here, inside the right triangle, and make an obtuse triangle. And we'll do that on the next page because there's not enough room here. Okay. So what happens then? What happens when the opposite side of A is greater than the height, but less than the other side given? You get 2. Yeah, because this here, this side length, since it's 4, can also be positioned over here, sorry. Can also be positioned over here. And that's another triangle. See that? So 2, all right? So I'm gonna write it down in here. Do I need to write in words? Okay, we'll write in words. So when A is greater than the height, but less than the other side given, you get two triangles. Are possible. Uh-oh. Now we're gonna write that in symbols, okay? We're gonna have to write that in symbols because it's quicker to write it in symbols. So that means when A is greater than the height, and then when A is less than the B or less than the B, do you see what I'm talking about here? So A, the opposite side given is greater than the height, and the opposite side given is less than the other side given. Does that make sense? Then you can have, then you will have two triangles. Now, I'm going to draw you the other triangle on the next page because there's not enough room there. So on the next page, so we'll draw a different triangle, it says. So what is a different, another triangle here? So if you're drawing the same thing, this is 30 degrees, this is 6. We know that the height is 4. We know that the height is 4. That means another triangle. Oh, no, sorry. The height is 3, sorry, but we're given a side length of 4. So that means I can position my triangle, my 4, I can position it here or inside. Here. So here is my other triangle. So this is 4. So my other triangle then is this one here. Let me change this color. This is my other triangle. You see that? That's the other triangle. And now let me show you. All right. What happens? Where are you going to find the supplementary? Remember the supplementary? That means if I may extend this one here, the supplementary angles are here. Okay. These are the supplementary angles. This one. Okay. And this one. Is that right? Because this is your triangle. So you have two triangles here. You have this one and this one. Okay, sorry, I can't draw. So this is the other one. So that later on, when you're solving this, you're going to have to find the angle first. So you need to find this angle first. Find this angle. And to get this angle here, you need to subtract from 180. Because you're going to have to solve two triangles, remember? So if you get two triangles, the first thing you're going to solve is the half pair. Okay? Your half pair, you're given the side opposite and find this angle. The other triangle will be the supplement of this, which is object. And you can solve this other triangle. All right? We'll have examples. Okay? Now let's go to the last one. So this one is the left side is 6. Side 6. You know, I'm going to change it to 8 because 6 is equal to that. So you won't have a triangle when it's equal to the opposite side given. So can you change this to 8, please? Let's say it's 8. So again, we have a triangle. Here is A. Here is B. And the opposite side is H. And this is 30 degrees. And the side given is, the other side given is H. Oh, sorry, guys. What should this be? 6. Okay, let me write it down. A is 30 degrees. B is still 6. And this time A is 8. And the minimum required side length to make a triangle is 3. That's our height. Now, if I have 8, okay, if this is 8 and this one here is 6, can I make 2 triangles or just 1? So 8 is longer than 6, right? I can only make 1. If I extend this longer, then I can try and fit, let's take that off. I can try and fit 8, okay? I can try and fit 8 over here, longer than the 6. Is that right? Now, can I position that 8 to the left of the height? No, because I would pass my angle right here, which is not possible. We can't go backwards with our angles. That's where we stop. That's where we stop. So when we move that over, it's going to go past. Then that means we only make 1 triangle. Okay? So how do we write this in symbols? I think we get it now. So when A is greater than the height, and what? Greater than the what? And the other side given, or the B, we have how many triangles only? 1 triangle only. And we know why. Can you imagine why? Because you can only position it to the right of the height and not backwards, not to the left of the height, because you're going to go past the 6 side lengths. Does that make sense? All right. So what about in an obtuse triangle? Obtuse triangle is so easy. You don't even need to find the height for an obtuse triangle. So let's look at this one. So we are given an angle of 120 degrees. So this is so easy. 120 degrees. And the side length B is 6. And A is 4. All right? So if we draw this is 120-degree angle. So here's your 120 degrees. What do you expect the side length of the 120 degrees would be? Your B here is 6. It says 6. And the A given is 4. What would you expect the opposite side of 120 degrees to be? The largest side. So is 4 larger than 6? No. So, well, basically, no. A is too short in here. So A is too short. So in any obtuse triangle, so obtuse, see this one, 120 degrees. When A or the opposite side given is less than the B, no triangle. Now we know what this is, okay? We know what A is, don't we? A is the opposite side of the angle given. B is the other side given. So A is always the side opposite the angle given, all right? So what happens if the side length or the A given is greater than the other side? Can we make 1? Yes, yes, yes. So here, same thing. We have 120 degrees. B is 6. And then this time A is 8. So is this possible? 120 degrees, H, and 6. Yes, this one is possible. It's longer than the 6. So here, if A is greater than the B, then we have 1 triangle. So in any obtuse triangle, we can only make 1 or 0. Okay? Any questions? Now let's go to some examples. Oh, wait a minute. We have things that we need to fill out yet. So when you are given 2 side lengths and an angle measure that is opposite to one of the sides given, you may be able to construct and solve how many triangles? 0, 1, or 2 triangles. Okay? Construct and solve. All right? So we're going to have to solve. We know how to find the height of a triangle. All right, so we're good. Let's see. This is review. So let's just review here. Looking at the numbers, I just want to look at the numbers. Let's find the height first. I gave you the same numbers, eh? So sine of, in here, we have to find sine of 30 degrees is equal to the height over the other side given. So h is equal to 6 sine 30. These are exactly the same numbers. I don't know why. H is equal to 3. So now looking at the top, how many triangles are possible? 0. So here, A is what? What is A? 2. A is less than the height in here because A is 2 and the height is only 3. And the height is 3, sorry. Height is, no, I had them switched. Okay. So A is what? A is, let me see. A is 2 and the height is 3. So it's shorter. So no triangle. What about this one? The height is, we know, is 3 and A is 3. So 3. The height is 3. A in here is equal to the height. So 3 is equal to 3. How many triangles? 1, right. This one, let's say. So A here is, the height is again 3. So A is 7 and the height is 3. So A is greater than the height. 7 is greater than the 3. Now, we know we're going to have a triangle here, but how many? That's the question. Are we going to have 2? We're not going to have 2 because look, remember on the back, we say that A should be less than the other side given. So is A here less than the other side given? A is bigger here, isn't it? So A, which is 7, is greater than the 6. So how many triangles are possible in this one? Only one. Because again, imagine the B is 6, and if you position it to the right, you can fit it, but you can't position it on the left because it's going to go past your 6 side length. What about this one here? So definitely A here is 4. A is greater than the height for sure because we have 4. Height is only 3. But we have to compare the A and the B. So A is 4 and the B is 6. Is A, so that's less, right? So A is less than the 6. So how many triangles are possible? Sorry. A is less than the B. So we have A is 4 and it's less than the 6. Therefore, here we have 2 triangles because we can position it to the right of the height and we can also position it to the left of the height because it's not going to go past the 6 side length. For this one, 120 degrees. Look at the side opposite A. Opposite angle A. Is A greater than or less than B? So here A is less than B. 4 is less than 6. Are we going to make a triangle? No, the opposite side cannot be smaller. The opposite side of the obtuse angle cannot be smaller than the other side. So therefore, no triangle. What about this one? Here we have A, 8 is greater than the B. 8 is greater than the B. Is this one possible? Yes, we have one triangle here. Any questions? If you get this, you have to congratulate yourself because you know what? This is really hard for most kids. Do you understand when you're going to make 2 or 1 or none? Okay, let's have some examples. So in triangle ABC, again, this is a side-side angle. And every time you have a side-side angle, you have to check the height first. So let's see. So we're going to draw this, and we're not sure if we're going to make a triangle or not. And the angle given is the base left. The other side given is the base right. The angle, the pair of the other side given with the base right. So this is 50 degrees. And A is 8. And then the B is 6. What should we do first to check if we can make a triangle or not? Find the height. We need to know if that side length is big enough to make a triangle. So we find the height. So this is SOHCAHTOA. So sine of 50 degrees is equal to the height. This is what we want, the height. Height over 6, the hypotenuse. So now h is equal to 6 sine of 50 degrees. What's that equal to? So 6 sine 50, 4.59 or 4.6. What's the unit? They didn't give us it. All right. What is it? Centimeters. All right, now question. The height is 4.6. We are given the opposite side of 8. How many triangles can we make? Only one, because 8 is too big, right? You can't position it to the left of the height anymore, only to the right side. So here, you only have one triangle. Therefore, only one triangle, right? Do we know why there's only one triangle? Why? So in here, I'm going to write it in different colors. So we know here, our A is greater than the height, and our A is also greater than the B, the other side given. And so we get one triangle. Now it says, find the measure of angle B. So since there's only one triangle, we have to construct the triangle. So we have to draw a triangle. So the triangle looks like this. We have to construct it. A, B, and then this is 6, this is 8, this is 50 degrees. There's only one triangle, so that's the only one we've got. And it says here, find angle B. So we need to find angle B. This is the angle we want. And sine law, that means sine B over 6 equals sine 50 degrees over H. So sine B is equal to 6 sine 50 degrees over 8. Sine -1. Now we need to see what that is equal to. 6 sine 50 equals divide by 8. So we got 0.5745. And B is equal to shift sine 35 degrees. So they ask us to, okay, no decimal. So that's our answer. Any questions? Now let's go to next. So given each SSA situation for a triangle ABC, that determine how many triangles are possible. So what do we do to determine how many triangles are possible? Find the what first? Height. All right, so let's find the height. All right, do we need to draw? So maybe we'll draw. So we have 40. A opposite is 4. Here is A. Here is B. Somewhere here, we don't know if we're gonna make one. And here is our 12. So find the height first. Sine of 40 degrees is equal to H over 12. So H is equal to 12 sine 40 degrees. And H is equal to, let's see, 12 sine 40, 7.7. Is that long enough? Is that long enough? Is our opposite side long enough to make a triangle if the height required is 7.7? No. So in here, our A is less than the H. Therefore, how many triangles? None. No triangle. Any questions? Let's go to the next one, letter B. So this time we're going to draw again. So we're going to draw this. We have 70. Okay, that's too small. 70 degrees. And then we have opposite side of 13. And then the B is 12. We need to find the height first because it's an SSA. So let's see. Sine of what? Equals H over 12. Always the half pair. Okay, always the half pair you divide. So H is equal to 12 sine 70 degrees. H is equal to, I don't know, 12 sine 70 degrees. We have 11.3. All right. Can we make one? Or two? We can't make two. Why not? You have 13, right? So you can position that 13 to the right, but not to the left of the height because you're going to pass your 12. So how many triangles are possible in this one? Only one. And why only one? Because A is greater than H. And A here is greater than the B. Therefore, only one triangle possible. Now, I hope you realize that later on, if you get one triangle, you got to solve it. If you get two triangles, you got to solve it. The triangles, I mean. Okay, let's go to this one. Can you try this too, just for practice? Do it on your own. All right, let's see. How many triangles did you get for letter C? One. For letter D? Two. All right. I think we're good. Okay, I have that down. Okay. You have the same numbers? You understand when to get 0, 1, or 2? And you know how to solve the triangles once you get 2? Find all the sides, find all the angles? Yeah. All right. So here's your homework. You know what your homework is, right? Tomorrow. Now, guys, my examples are all ABCs, but some of, most of the questions will not be ABCs. Like this one here, we're going to do that tomorrow, Monday. and I have drawings there. Here is your homework, all of this. I'll give you a little bit of time to practice, and I forgot to ask you questions if you had trouble with the textbook. Is there anything you want me to go over from there? No, are you sure? All right, good. I trust you.